So today we'll talk about solving word problems, especially in this chapter with fractions. And that's really important because if you can solve regular problems, but you can't solve word problems, it sort of means that you're having trouble applying the math in real world situations. And that is ultimately the point of all of this, is to be able to apply it. So the book talks about a few problem solving steps. First of all, and we talk about this so often, but it's really easy to miss this step, is to truly understand the problem that's being posed. And that may involve reading the problem really carefully. I find that drawing a picture is absolutely essential, but I'm more of a visual learner, and that's one of the reasons why I like those fruit videos so much, because they're really visual. But that may not exactly work for you, so we'll see. The book also talks about filling in what it calls the mathematics blueprint, and that is, we'll talk a little bit more about that in the next slide. Of course, then the next part is to solve the problem and perform the calculations that you have in mind in terms of addressing the problem. And then important is to really articulate the answer, including any kind of units, say if the answer should be in inches or feet or pounds, whatever, meters. And that, because being able to state the answer as part of a sentence means that you understand what the problem is about, basically. And then the last thing that a lot of times people forget is to check the answer. And you should stop and think whether the answer would match kind of your estimate of the answer. And a lot of you have a lot of real world experience and have a sense anyway of what a ballpark estimate of the answer. So use that common sense that you have. And so those are the three basic sort of problem solving steps that the book talks about. So the book offers as one approach what it calls mathematics blueprint, and that for some of you is a kind of it might be helpful as a series of steps about how to solve a problem. I, for one, tend to rely a little bit more on just drawing a picture and figuring out the steps from there, but that's because I'm more of a visual learner. But for some of you who need something kind of step by step, using this mathematics blueprint might help. The first thing is to gather the facts about a problem, and that would involve like a really careful reading of the problem and maybe circling what feels like important facts. Always the word problem or the application gives you some facts to begin to work with. Then the key part is, what am I asked to do? That is, like, what is the problem? What is the problem about? What is the answer going to look like in the end? Is it, are you being asked to find the area of something, or the dollars that you're going to have to spend, or something like that? So what am I asked to do is really about what's the nature of the answer that you're looking for in this problem. And then how do I proceed is really about thinking about the calculations that would be needed to get to the answer. Okay. And key points to remember might be things like the specifics of the math that might be involved. So, for example, some tricky things with fractions, say finding a common denominator, or remembering to flip the second fraction when you're doing some kind of division, and so forth. So that kind of gives you a sense of what's going on with the mathematics blueprint. But let's look at an example. So here's an example of a word problem with where we're looking at mixed numbers and doing some applications of that kind of thing. I'm going to draw a picture sort of as I read through the problem to help me understand it. Carpenter is using an 8-foot length of wood for a frame. He needs to cut a notch in the wood that is 1 2/3 feet from one end and 4 7/8 feet from the other end. How long does the notch need to be? So, got an 8-foot piece of wood. going to put the key facts right in my picture. That's what I like about drawing pictures. All right, and then the notch starts 1 2/3 feet. That's maybe about here, say. 1 2/3 feet from one end. And then there's a notch 4 7/8 feet from the other end. That might be like about here, starting from this side. Okay, and so then the question is, right, so this is where the notch starts and it goes all the way to this point. So the question is, how long is that? That's the question. And it's they want it in feet, so it's some kind of length. How long is that notch? So one way to think about it, first of all, is what's not included in the notch, and that would be the 1 2/3 feet and the 4 7/8 feet. Those are not being carved out as a notch. So let's think about what's not included. Okay, so if you knew how much was not included and you subtracted that off from the 8 feet, then you'd have the answer in terms of what is included, right? Take the whole thing, subtract off what's not included in that notch, and then that gives you your answer. So first of all, we have to figure out what's not included. Well, there's 2 pieces, so together you'd add those up together to figure out what's not included. So that would be 1 2/3 plus 4 7/8. So we need a common denominator here. So that would be 1, 1, and 16/24. 3 times 8 is 24. So that'll be a common denominator that we can use. 4 and 21/24. Okay, so really we're going to work this problem now. We've got common denominator. So we have 5 and 37/24. It's looking kind of ugly, actually, because that's an improper fraction there in that mixed number. So let's see what we can do. So 37/24. If you subtract out 24/24, take a 1 out of that, that's going to be 6 and 13/24. Okay, so that's the part that's not included. That's the part here, over here, and here. All right. So out of the 8 feet, then 6 and 13/24 feet is not included in the notch. So we got to subtract off this part that's not included, and that will leave what is included in the notch. So let me just go to the next slide. Okay, so here's a word problem where we were adding mixed numbers and then we end up kind of subtracting some stuff too. So just to finish off that problem, what is going to be included in the notch would be the whole 8 feet, the whole board. Then you're going to subtract out the part that's not the notch. That's 6 and 13/24. And then whatever is left over is the part that it does get notched for this carpentry work. So let's see. So the book says you usually want to kind of stack these problems vertically. Okay, so there's a problem here because we don't have any fraction up here to subtract this 13/24 from. So we have to borrow one from the 8. So if you remember from your reading in the book, and I encourage you to do the reading in the book, that we could write this as 7 and 24 24ths. Right, that's the same as 8, right? 7 and 24 24ths. Yeah, it's kind of awkward, but it is the same as 8, so that's fine. Minus 6 and 13 24ths. Okay. 24 24ths minus 13 24ths. We've got a good common denominator there. So that would just be 11 24ths. And then 7 minus 6 is 1. So the answer then about the part of the wood that is included as the notch, the thing that needs to be carved out, is 1, 1, and 11 24ths feet. And we know that 11 24ths, that's reduced because there's nothing that goes into 11 that also goes into 24, except 1, of course. So if we think about what the previous slide said about the problem, we had this 8-foot piece of wood. The notch starts here, and then we start a notch from the other side about there. And then the question was, how long is that notch? The answer is 1 and 11 24ths feet